All right. So we are continuing on discussing some geometric objects in ggplot, and there are lots, a lot available. And so if you go to just if you type in ggplot to Google, okay, first hit will be ggplot reference ggplot2.tidyverse.org, okay. And within this there's a couple of things. There's the cheat sheet, which gives you like a little thumbnail of what some of the different geometric objects are. And then also under reference there will be a list of all of the different kind of geomes that you can add, right? And ggplot, you add layers, so you can combine and mix and match a lot of these. Okay, some of them like don't mix well with others. Like it's going to be tough to add a bar plot to a histogram just because they're kind of similar and stuff. But yeah, a lot of these kinds of things we saw examples where I did points and then I added the path, so the line connects the points and stuff like that. And the cheat sheet. Let's see if I open this. Here's the cheat sheet, and it just kind of shows a lot of the different things. Okay, so you have you know, I don't know, whatever yeah, whatever these things are, right? So we've seen geom point, but you can also add smooths and these different kind of examples. You can also look up examples of ggplot and things. So lots of choices. I think point is probably one of the most useful ones, and we spent a decent amount of time there. And I encourage you in your homework, but also just kind of on your own, start exploring and start kind of just playing around and start seeing what you can do. There, you have some example data sets available in the homework. In the lectures that I've covered, you've seen some examples with like the penguins data set and stuff like that. And those are, I think, all nicely formatted and in a form that you can start to kind of play around with. Later on in our course, you're gonna do a group project, okay? And for the group project, you're gonna find your own data set. And you're gonna find that when you go out and you start looking for your own data set, there's different issues that come up, and sometimes the data is not nicely formatted. And so that adds like a whole kind of initial hurdle that you have to get through. And I'll show you some tools and things to kind of get through that part. But as far as like just kind of playing around and interacting, some of the data sets that you see in the homework and in the notes so far, they're all kind of already pre-formatted, and they're nice and ready to go for you to kind of just start exploring. And that's really going to be the best way for you to learn, okay? Is, I give you homework on data camp, I give you homework in these things. But just like, if you're going to learn a sport or learn piano or something, like the best way is to just start doing it yourself, okay? Don't limit yourself to just when you're given, instructions. Okay? I know you still got to balance all of life and stuff, but so anyway, we talked about geom point, and we have that. And so today I'm going to introduce geom column, which is what we use for bar charts, bar plots, which is really helpful. And then we'll also just kind of touch on geom line, which is geom line, geom path. Those things exist, and even if we don't get to geom line, you can kind of look through those slides on your own, look up examples. It's not too different from the way we use geom points and stuff. So, but I do want to talk about geom column. Again, examples from our textbook and things. Okay, and then referencing lots of other geometries there. Okay, so we're gonna start by loading up the tidyverse, and then this library, G Cookbook, contains some of the data sets that we're going to be using. And again, if you try to run any of these things like library and it says, hey, package doesn't exist, you just go over to the packages pane and you click install and you add the package that way. All right. Or you run it in the console, install.packages, you type out the console name. All right, type out the package name. Okay, so let's talk about bar graphs. So as far as bar graphs go, we're representing our data with these, rectangles, these bars or these columns or things like that, okay? And so in our data, we'll have, generally, we have a column that's going to represent the X position of each bar. Usually it's categorical, but it can be numeric, X position. So if you think about different columns, the X position doesn't necessarily have to be a number. It could be something like, for group 1, and that's going to be located at this location on the X-axis, and group 2 is going to be over here, and group, this team or that team, okay? And then you have another column representing how tall each bar should be. So this comes from a data set called plant growth, all right? And I don't actually know what happened here, but there was a control group and treatment 1 and treatment 2, and there's like 30 entries here, and we just see the first 11. They did some kind of experiment. They dried out the plants, and then they weighed them at the end of the experiment. And so you have, control and treatment 1, and I don't know. This is, again, a lot of statistics data had kind of roots in agriculture and botany and things like that, where they grew plants and stuff. So you look at all of these older historical records, and it's like, oh, we grew radishes in light and darkness, and we wanted to see what effect it had on the growth of the radishes, which I guess back then that was like cutting edge science. Now we just know, yeah, plants need light to grow, but that was confirmed, through experimentation, right? I mean, it's kind of like this logical thing, people knew that, like, oh, you didn't, but anyway, this we will cover in a future lecture. But what we've done is we've taken basically these 10 values for control, and we calculated the mean weight, okay? And then there's 10 values for treatment 1, and we calculated the mean weight, and then 10 values for treatment 2, and we calculated the mean weight, okay? So that is contained in this table called plant growth mean, or PG_mean, and it's just, hey, what is the mean weight for control? What's the mean weight for treatment? What's the mean weight for treatment 2? Okay. All right, so this is just like a very simple example that lends itself well to a bar plot, okay? And what we're gonna do, like, again, you could imagine if you're in, I don't know, 6th grade, and we say, hey, make a bar plot with this, what would you do? You would, I don't have a, I think this works. You just go, okay, I'm gonna put control here, and then I need a vertical axis. Here's 5, and we're gonna draw a rectangle at 5 there, and then I've got treatment 1. And so just imagine, what would you have to do in your 6th grade homework? You would draw something like this, right? And that's exactly what ggplot will do, okay? So what are we doing? On the x-axis, we're putting the group. How tall is each bar? That's going to be associated with the weight, okay? I don't know if it even shows up on the screen there, but yeah, that's what we do. So we say, all right, ggplot, we're taking this table here, PG mean, the aesthetics, we're putting the group label on the x-axis. The height of each bar, okay, is the weight. And then the object that we're drawing, they call this a column, okay? So we're using geom_column, okay? And theme black and white just says, I think by default it uses like a gray background, and black and white just says, you know what, I want a white background with thin gray, thin lines, all right? And so this is this is what the plot looks like. All right, so not too far off from what we had here. Okay. You have options. Okay. So these are not these don't convey data. These are just settings here, but you can associate it with if you had something else in the data. Our data was super simple. We don't have any additional variables, right? But I could have like another variable that was like treatment 1 under, I don't know, maybe we had different species of plant. Okay, so treatment 1, and this was like the bananas, and treatment 2 was the apples, or something like that. Okay, and maybe we want to convey that. But you have different options as far as conveying additional information. Here I just have settings, but we can change the fill color. This is light blue, is the internal fill. Okay, you can also change the outline. The outline is color, right? So it's a little weird, but color is the outline of the column, and then fill is the internal color of the column. Okay, and then you can also affect how wide the line is. I don't know if that's a good use of an aesthetic as far as conveying data, because I don't think people really notice super well, like, oh, this line is thinner and that line is thicker, and therefore I'm understanding something different about the data. Okay, so probably not the best case. But fill color, people immediately notice fill color, and that can be useful for conveying information or different aspects of the data. But these are just different things that you can kind of mess around with. Okay, another thing you can change is the width of the bar. So here, one of the options is changing the width, and you can have the width convey information itself, or you can just set it, okay? And the width is basically anywhere from 0 to 1, and it's if you have width equal to 1, there's basically no gaps between the bars. Okay, I think the default is 90%, and so I don't know. There's kind of like a 9-to-1 ratio between the width of the bar and the width of the gap. But if you want bigger gaps, you can do that. I don't know. This is more just of a like, do I like the way it looks kind of choice, not actually. Again, any of these things can be associated with an aspect of the data if you want to try to convey some kind of information with this visual property. So if you want to have the width of the bar convey something about the data, you can. I would just caution you and say it's probably not the best way to represent your data. Okay. Okay. Here is some fictional data. Okay, and now we're going to try to convey a little bit more information here. So I've got sales information, and then we have 2 categorical variables. We have team and we have the day or the date. Okay, so we have team A and team B, and then we have date, Wednesday, Friday, Saturday, Wednesday, Friday, Saturday, and then we have sales figures. Okay, and so we could say, all right, they sold 240 units of whatever paper. Okay, something like that. Right, and then so we want to see, like, okay, which team performs better, what days perform better. I don't know. Okay, we're kind of going to try to do this. All right, and so this is our data. So the first thing is we can create what we call side-by-side bar plots. Okay, so here I'm putting date on the x-axis. So I've got Wednesday, Friday, and Saturday along the x-axis. The height of the bar is the sales number. And then we're going to fill based on team. So red is team A, and whatever color this is, kind of bluish green, is team B. Okay. And position dodge here says put them side by side. Red over here and blue over here. Okay. Team A is over here and team B is over here. All right, and so what we notice is we can see red is taller than blue over here. Red is taller than blue. So your brain generally tries to, like, when things are touching each other, okay, you notice like the height difference, right? So because these are touching, like, you immediately notice these things. And yes, you can also see the difference between this column and this column. But because there's a little bit of a gap, I think that difference comes a little bit secondary to the ones that are adjacent and touching each other. I think my personal, the way I kind of perceive this, all right? And so we kind of see that. Another option, okay, is I could set team to be the x-axis on the x-axis. So I've got team A and team B over here. And then as far as the fill color, I'm going to put date. Okay, so now we have Wednesday, Friday, and Saturday. Okay, this is the exact same data. Okay, it's the exact same data. All we've done is we've just changed what gets mapped to X and what gets mapped to team. Here we're just swapping. Okay, and so now the immediate comparison is what's kind of touching each other. So we see Wednesday, Friday, Saturday. All right, and our eyes are drawn I think a little bit more to the fact that, okay, Saturday is higher than Friday, which is higher than Wednesday. Saturday is higher than Friday, which is higher than Wednesday. Whatever I was saying. Okay, and then yes, we can compare A and B, and again, but I think because of the gap, the immediate comparison is the adjacent ones, and then the one where the gap is a little bit secondary. Right. So that's, again, what are you trying to convey? Okay. And so I kind of commented this. So when fill is the team, the teams are adjacent, and we easily compare the difference in performance between teams. Okay, and then when fill is date, our attention is drawn more to the difference between the days. Okay, this is the exact same thing. All I've done though is, again, sometimes the values themselves. Here I've just shrunk one team. I've got team C and team D, and team D's numbers are way smaller. Okay, and so this is going to affect some stuff. Okay, and so here's one plot. Okay, now to kind of pick different colors, I use scale fill manual. Right, and you can put in named colors, and you can also put in hex codes. Are you guys familiar with color hex codes? Okay, so if you're not, you can do color picker. Okay, and whatever colors you want. So you get all of these things, and then there is what you call the hex code, and this is kind of this universal thing. And basically, you have 256 levels of red, 256 levels of green, 256 levels of blue. Okay, and so so black is all three values are 0, and white is all three values are max. Okay, 250. It goes from 0 to 255, and then if I do like 0, 0, 0, 0, 2, FF, which is 255, that's like pure blue. I don't know. You guys learned about like red and blue make magenta, and red and green make yellow. Okay, and like blue and green make cyan and all that. All right, so anyway, you have all of this, and you can pick any kind. So this is your hex colors. There's a list of named colors also in R. And these are colors that actually have names. An overview of color. Okay, well, I don't want to. But like you can say, I want navy. All right, and the navy corresponds to a certain color as well. But anyway, going back to this. Okay, I just picked. I think these are the official hex colors for UCLA's blue and gold. Okay, but anyway, this is just to kind of pick this out. All right, and so with this, like, because of the dramatic difference between the height of the blue and the yellow, it's like, okay, yep, they're different. Okay, and then I could also do it this way, where I have Team C and Team D, but I've got Wednesday, Friday, Saturday. Okay, and again, we see kind of these differences here. And so again, either of these things really, I think your eyes are drawn very, very much to just the fact that this one's way taller than that one, and maybe that's the point. Okay, maybe that's the point. Okay, so those are the side-by-side bar plots. We can also, rather than putting the different colors side by side, we can also stack them on top of each other, all right? And that's the stacked bar plot, okay? So the key here, so I do the same kind of thing. X is date, Y is sales, fill is team, okay? So I have two colors for team, but now position is stacked. And so rather than, so with position, for the side by side, we had position equals Dodge, okay? So the red is on the left and the blue is on the right here. Here we're stacking them on top of each other, okay? So this is a stacked thing, okay? And so this, I think the primary thing you notice is just the total height of the bars first, okay? So we see, okay, Saturday is higher than Friday, is higher than Wednesday. It's really tough to compare the height of this orange red with this red and this red, okay? Because these are all aligned at the bottom here, we can kind of compare the blue down here. But if I said, hey, is this red taller than this red? Like, you kind of have to stare at it a lot harder to try to figure that out, okay? Another option, as far as stacking goes, is you can, if you do position equals fill, okay, so not stack, but fill, this is a different kind of stack thing, and this makes the top equal to 100%, okay? So you lose the raw numbers. So over here, Saturday is higher than Friday, which is higher than Wednesday. Over here, Saturday, Friday, and Wednesday all are 100%. And so what you get now is you get within Saturday, you know, did team A or team B have the higher proportion, okay? And if you look really closely, team B is just slightly over 50%, okay? And then over here with Friday and Wednesday, team B is slightly below 50% and things like that. So this draws more attention to kind of the proportional differences there, okay? Sometimes the proportional difference is the only way to really show, to notice certain kind of patterns in the thing, okay? So here I have the team C and team D, where team C, again, greatly outperformed team D, okay? And here it's stacked, and we just kind of see these things. And again, it's kind of tough to, you know, make too much reason, okay? Here I have them proportional, okay? And we can see this is level across all 3 days. And so as far as their comparative performance, team D, I think, is like 10%, and this is also 10%, and this is also 10% or something like that, right? Maybe 9%. But it's level across all of the things. And so this, you can kind of say, like, you know, even though the numbers are bigger, you know, Wednesday, Friday, Saturday, if you look at the kind of the proportional things, we see it's kind of the same. And so sometimes proportional things can draw attention to, you know, certain aspects. So you can say, like, all right, despite only being, you know, 1% of the population, this group of people is, like, you know, victims, you know, 30% of the time or something like that, okay? And that can kind of show certain disparities between, you know, different kind of groups and stuff like that. And so you can, you know, say, as far as, you know, kind of proportional things. So you can show, like, in one column would be kind of just like general population, and you have, like, you know, certain group makes up only like 9% of the population. But then perhaps if you talk about, like, victims of certain crimes and stuff, they might show disproportionately high or something like that. Okay, something. All right, I don't know. And so these are just some comments regarding stacked bar plots. So again, a thing that I'm going to kind of keep going back to is this idea of what is it that you want to communicate with your graph? What is it that you want your viewer to notice and draw attention to? And you want to have that in mind as you're kind of preparing your data, okay, or preparing your data visualization. Okay, it's not necessarily like we're not trying to manipulate or present like biased information or something in some kind of bad way, but a lot of times there is something that needs to be communicated, something that you want the viewer to understand from the data, and you keep that in mind as far as how do we make sure that is visible and communicated in our charts. Okay. I forgot. Let me give you your. Do I have it set up here? Okay. I have to pull this up. View quiz answer for today. All right, it's still loading. Okay, here's the same kind of thing, but now you can also, I said team is on X and Phil is the date. And so as far as this goes, now we have 3 colors stacked on top of each other, and that kind of looks like that. Okay, when you have the different proportions, the different amount is very clearly visible. All right, so it's hard to kind of, like if I said, hey, what's the proportion red versus green versus blue here? Really hard to kind of tell, okay? And that's when you do like the stack proportions and we say, oh, red is the exact same size as green, is the exact same size as blue, for team A or team C and team D. Okay, so, okay, first answer is the letter A. A as in apple. A as in apple is your first view quiz answer today. A. Okay, here is a little bit of an older data set where I guess they took some population numbers and they were comparing population in the year 2000 and the year 2010. Okay, and they asked how much did certain states, how much did their population change? And so, we just did a census. I don't know, just did, but a census was conducted about 5 years ago in 2020. I think we have updated numbers, and certain states definitely have grown. I think Nevada is still rapidly growing in population. But anyway, this is kind of what the data looks like. And here I'm sorted by change in descending order. Okay, and I'll and I'm using the old pipe here, but we'll cover how to like kind of what we say wrangle our data using dplyr, and that's going to be kind of our next lecture. But for now, I'm just kind of sorting them from biggest to smallest, and I'm just kind of taking the top 10. And so between 2000 and 2010, Nevada, Arizona, Utah, saw a lot of growth. Idaho grew a lot. Texas grew. Also, North Carolina, Georgia, Florida, Colorado, and South Carolina, I think, is number 10 that got cut off there. So anyway, this is our data set. We're going to try to use this to create some bar plots here, okay? And so one is I'm saying like, all right, let's put the state abbreviation on the x-axis. And so the default is it's going to arrange the x-axis in alphabetical order. Okay, so we have AZ for Colorado, AZ for Arizona, then CO for Colorado, and so on and so forth. And this is in alphabetical order. I don't know, how would you order the states? And I don't know. Alphabetical order, I guess. But the order in which they were admitted to the union. All right. So what's that? Delaware is number one, and so on. Yeah. Question.
Wait, is that alphabetical? Because why is Florida?
Huh? Yeah. It's alphabetical by
Oh,
yeah, by abbreviation. A Z A C F G. Yeah. So I mean, yeah. There's a funny like how the states got their abbreviations stand-up comedy skit. You can look at it. It's silly. It's my kind of humor, but which is nerdy, I guess. But so we have this. I don't know. This is just one kind of order, right? If you said I want the 50 states in order, and it's not alphabetical, I don't think people would come to some great agreement. Maybe order of population and stuff. Okay, so anyway, this is I'm filling by region, and so we have south and west. You could fill by other things. Here I'm putting change on the same. So change is the height of the bar itself. Okay, height of the column. But I'm also going to do the fill color is associated with change. And so now change is a numeric value, and so the one with the least amount of change is going to be our darkest color bar, and the one with the greatest amount of change is going to be our brightest color bar. We can arrange them. So here, again, it's still in alphabetical order, and you can say, well, I want to put them in order from the shortest bar on the left and the tallest bar on the right, okay? And so for that, I'm going to use this reorder, okay? So I'm going to say take X, and we want to put the abbreviation there, but we're going to reorder it based on change here, okay? And so we get now now the shortest bar is on the left and the bar on the right is over there, okay? And the x-axis here is labeled reorder ABB change, which is probably not great. And so we would probably add the labels argument, so we can just say like this is going to be the state or something, okay? But this is how you would change the order of the bars, okay? And so that's one thing about these bar plots, these column plots, is there's no right or wrong way to arrange these bars, okay? If you wanted to say like, okay, I kind of have a map of the US, and so on the west I'm going to put like California, and we're going to move kind of across to the right, so we're going to end up with like Florida and Maine on the right hand side. You can kind of do that. It's a little bit tough because what do you put, California, Oregon, or Washington all the way on the left? And there's probably no universal agreement there, but you know, as far as something like that, you can rearrange the bars however you want, okay? So here I'm rearranging them according to percent change. And so now this really kind of, you know, we have like the same information presented in two ways. We see it going from low to tall, and we also see it go from dark to bright blue. Okay. You can also, so you can set colors for categories using scale fill manual, right? And so we picked like the Bruin blue and gold. But here you can also set it for a gradient, okay? And so the gradient, you can do low and high. Let me see. Can I do a low, medium, high? So we have scale fill gradient. There's a mid. I did see a mid. Let me see. Breaks, low and high. All right. Low, mid, high. I don't know. Yeah, it looks like something. So I think I haven't messed around with it, but try it, okay? Here, I have it right here. Okay, so all of my slide decks are created using Quarto as well. So So the stuff I'm making you use for your homework, I use myself, okay? But let me see. Let me see if I can run all of this. All right. Was it mid? Mid equals, oh dear. Oh, I broke something. Okay. So what if I do mid equals white? Does that work? I don't know. Let's try it. No, it doesn't like that. Scale fill gradient, is it 2? Scale color. Scale fill, midpoint, mid, low, mid, high. What am I doing wrong? Midpoint equals 0. Oh, I have to specify. Midpoint equals, I guess, 25. Okay, there we go. All right, I don't like that anymore. Because that's, okay, midpoint, maybe 19 makes more sense. All right, something like that. All right, so yes, you can do kind of different things, but that's scale fill gradient 2, I guess, to have like 2 specified colors. The 35 is just really throwing things off here. I don't know. Would weird color? What's red to? I don't know. If I pick yellow, is that gonna do? Yeah, that looks whatever. Okay, so that's a choice. So custom thing. If you wanted to do that, I guess that's like I'm thinking of. Was it? It's like and the movies where there's like the steam valve and it's like green, and then as the pressure is building up, it goes into yellow, and then it goes into red, and things like that. And that's like when the train is reading off the tracks and it's gonna explode, and you have to get Doc to go in the time machine. Okay. All right. So that's that. All right. Oh, here's another data set. Okay. So here's like if you want to have ggplot do some counting for you, this is handled with geom_bar. Okay, so all of these other things we've been using geom column. Okay, but now we're going to do geom_bar, and then I'm not going to assign anything to y, right? And you go, well, and when you do it like that, then ggplot is going to say, okay, I'm going to figure out the y. I'm going to figure out how tall each of these bars need to be, and I'm going to count how many times a certain value appears. And so here's like this huge data set. It's called the diamonds data set, and there's like almost 54,000, I don't know, records of diamonds here. So I guess if you're like the diamond company, you know, you have somebody inspect your diamond, and then they grade the diamonds, okay? And they say, oh, this is an ideal cut diamond, and it's you know, this color grade, because it's like diamonds can go from yellow to like colorless, which is the most desirable, and then sometimes they contain impurities, and that's the clarity and things like that, and then how big is the diamond and stuff like that. Anyway, so that shows up here, and you can say, all right, well, let's take one of these categorical variables. I think I did cut, and if you do geom_bar, it's going to count how many times it sees ideal cut versus premium cut versus good cut, so on and so forth. Okay, and so here I said x equals cut, so we got fair, good, very good, premium, and ideal. Cut is what we call an ordinal variable. It's like a categorical variable, but there is a natural order to it. So it doesn't go, this is not in alphabetical order, right? Very good, V is not after, like in alphabetical order, it would not go in this order. But there is a natural order. It's kind of like size, small, medium, large, okay? And it's kind of like I don't know, degrees of how good these things are. So this is what we call an ordinal variable. So it's categorical. So you wouldn't want to rearrange the bars, right? With like the states, what order should the states go in? Nobody really has strong opinions about that. Alphabetical order is just as good as any other order. But as far as the cut goes, it's like frustrating if you go to the clothing store and the clothes are not arranged from small, medium to large, and it's just kind of like all jumbled up. You get frustrated, right? And if you don't arrange these in the right order, you get frustrated too. Yeah, question. So it is stored inside the data you specify. And so this column says ORD, which says this is an ordered variable versus, so yeah, on its own, R doesn't have the intelligence to know this is ordinal, but you can kind of store it inside the data, and then part of the additional information that goes behind an ordinal variable is like, this is the order in which it goes, like fair is lower, premium is better, perfect or whatever, ideal is the best. Yeah, question?
Do they using levels?
Yeah, so that's the levels is how it stores the order in which these categories should be arranged. Yeah. Okay, so anyway, this is an ordinal variable. It shows up like that. You can specify something like this. So here I'm doing fill equals color. All right, and by default it kind of stacks them up. Okay, and I don't know. That's that. Okay, so geom_bar, again, I haven't specified anything for y. Okay, because it's figuring out the y by doing the counting itself for a big data set like this. Okay, here under geom_bar I'm doing position equals dodge, and so now we get this side by side kind of, the bars are side by side. And so there is kind of like an interesting side effect of this, is that we see almost like this normal distribution. We haven't really talked about normal distributions, but kind of like this bell curve of like, as far as the colors go, D being the best and J being the worst, like there's not a whole lot of J, there's not a whole lot of D, and there's kind of more in the middle. And we kind of see a similar shape of like the end sizes being a little bit lower, and then the middle ones being a little bit higher, and things like that. Okay. Whereas that is probably not as readily apparent when it's stacked up like that. Okay, but I don't know what's better. Again, and then here is where it's filled. It adds up to 100%. And what do I notice here? As far as the worst color, which is J, okay, it seems like fair has the greatest proportion of J versus the other ones, but it's kind of tough to draw super strong conclusions, okay? As far as like the lower grade colors, we see a little bit more of these things. And here I put color on the x-axis, and then cut as far as the fill color here, okay? And so there's kind of this other thing where there's more ideal than any other cut, and that's like that holds across the board. Okay, but it's so we see ideal being the tallest for all of these things. Okay, I don't know. That's what we got there. Okay. I'll go ahead and give you your second and third answers. Second is B, and the third is C. Okay. Second is B, and your third answer is C. Okay, line graphs. Line graphs. So it's kind of just like, think of like geom point. It's kind of like that. You have like a numeric value on the one value and another numeric thing. And so you map one to X, you map the other to Y, and you get this, okay? And And that's it. And it basically, instead of putting points, it connects them with lines. All right. And that's that. That's geom_line. We have geom_path. Okay. So for depending on your data set, my geom_line and geom_path look exactly the same. And that's because a geom_path goes in the order that it appears here. So here it appears like this, and it goes 1, 2, 3, 4, 5, 7, and so it just kind of prints 1, 2, 3, 4, 5, 7. Geom_path shows up whatever the order is. So here I've arranged it now by demand, okay? And so notice the time goes now 1, 2, 5, 4, 3. 1, 2, 5, 4, 3. So now that it's been rearranged, geom_line still goes off of X and goes 1, 2, 3, 4, 5, 7. Okay, but geom_path follows the order that it appears in the data. What was it? 1, 2, 5, 4, 3, then 7. Okay, so path will follow will connect the line and how the data appears in the table. Okay, whereas geom_line will internally think about X being small, X being large, and connect in the order of the X-axis, or in the X. And here it follows this, right? If you have geom_point, the point plot would look the scatter plot would look exactly the same, right? Because the coordinate of X and Y is exactly the same, right? This point is here, and this point is here, and this dot, okay, this dot is right up there, whatever that is, 5, 16, okay? And that's this dot right here, 5, 16. But the difference is the path is different, okay? So that's going to be the difference between geom_line and geom_path, okay? You can draw multiple lines. So here I have something else here. I've got a categorical variable. This is from some experiment, and I have no idea who decided to run this experiment. This is like the stuff where there's all kinds of, there's, I hope UCLA wins all of its cases right now, but regarding research funding and stuff. But people like to pick out like, oh, look at this weird research. Like, why are we spending money on weird research? There's usually a good reason behind it. But here was some research where they looked at guinea pigs and they gave it vitamin C. They gave some guinea pigs orange juice, and they wanted to see what effect it had on like the growth of the teeth. Okay, I think there's bigger implications as far as like oral and dental health for humans, but you can't really do that with people. So you test it on these animals that don't have freedom. And so anyway, this is the thing. So we gave some animals orange juice. We gave some vitamin C. That's what this is. And then we gave them different amounts of dosage. And we measured how much their teeth grew. Okay. And this is the plot. Okay. And so here I'm saying, hey, I want to change the color of the line based on the category. Was it orange juice or vitamin C? And so we have different colors. You can change the width to make it a little bit easier. Okay. You can also associate the width depending on the value itself. Okay. And so if you have a numeric value, you can have like a really fat line. You can have a thin line. One of the most famous data visualizations was on Napoleon data visualization, Napoleon's Army March. Okay. This is kind of this is an old data visualization. Okay. And the width here portrays the size of Napoleon's army. So there's kind of, Napoleon tried to march onto Russia in the winter in Moscow, okay, and suffered a great loss, right? And so this is kind of when he left. He started off with this very wide line indicating strong army. As time went on, the line gets thinner and thinner, okay? and then he was forced to retreat, and he continued to suffer losses during the retreat. And so when he left Russia and he's retreating, it gets thinner, and you can see it continue to get thinner and thinner and thinner as it returns. And so this is kind of like one of the classic examples of data visualization where the width of the line conveys information. Okay. If you are printing something in black and white, maybe you want not colors, but different styles of line, solid line versus dotted line. That's an option there. All right, that's it. Have a great rest of your day. I got office hours at noon, and we'll see you guys on Friday.